Suppose we wanted now to actually timeshare the machine. If every some number of clock interrupts, we said, hey, I want to go run some other process. So let's say every 5th clock interrupt, I'm going to say, okay, it's time to go run some other process. Well, here's how that might work. I'm actually going to build myself a new array. Okay, this process table that looks like this is actually n copies of this user state. So it's a big array of these data structures, and I have, you know, something for process 0 and process 1 all the way up to process n. And there's a notion of there's a current process. So the current process is equal now to 2. I'm just reminding myself which process I'm running. When I call, and so this so-called process table here, that's what I've described here. So this is what in the slide is called proc table. Okay. So proc table is an array of all these structures, and you can see the way the scheduler works is it takes the place where the interrupt handler stored all the user registers and simply copies it into the current process. So it says, aha, I'm going to take all these registers that I saved away when I got the clock interrupt and I put down here in the kernel memory. I'm going to copy it to another place in the kernel memory, but this array here is specific to process number 2. I'm going to save it away there. I'm then going to change the current process to process 3. And then I'm going to copy all of process 3's registers back here. And then I'm going to go ahead and set up the page map, anything else I need to do to start running process 3. And then I'm going to return from the scheduler call. And when I return from the scheduler call, that means I'm going to return from the clock handler, which means I'm going to load up the registers. I'm going to load up the registers from here. So whose registers am I loading up when I return after calling scheduler? The registers for the new process, right? What I've done is I've sort of pulled a fast one on the clock handler. He says, look, I put a bunch of registers in there. I'm going to restore them. I pulled a fast one in the scheduler simply by swapping the registers that are in the locations that will be used to restore the actual hardware registers. So the scheduler is just sort of playing the shell game. You call the scheduler, it takes the listing of all the registers that the interrupt handler is going to use, copies them out, takes some new information, puts it in, and says, okay, now you can return from your interrupt, but now it's going to be returning to the black and white process instead of the color process. Questions about that? It's a pretty simple little scheme. Yes?
It also has to return, like, because if you just return to the same spot in the program that it left from, it would go back trying to do the old thing with the new things registers, right? So it also has to...
So one of the things that we've done, so how, if we look at here, where do I return to? I return to wherever the XP register is. So the XP register, R30, was where we say, that's the program counter that we saved away. So when I swapped the registers, one of the registers I swapped was the XP register. That makes sense? And so I'm actually returning to the save PC from process 3, not the save PC for process 2. So one of the advantages of putting the save PC into one of the registers is that our register swapping thing automatically switches the PCs that we're returning to. Okay.